Welcome to another video about, this one is about heat pumps, and in this video I'm going to tell you a wee bit about the principles of a heat pump, working principles, but I'm going to zoom in on how to calculate the coefficient of performance in a normal process and in a Carnot process. I expect this video to be very short because actually a heat pump is really similar to a cooling cycle. As you can see over here, I even didn't erase my cooling cycle because the working principle is actually the same. We absorb some heat somewhere and move it to another place and reject the heat there again. Actually, the objective of a heat pump would be to move heat from a cold area to a hot area, or even, maybe it's even better to say, add heat. So increase temperature in some region. So for instance your room or a sauna or whatever. Okay. So this is basically the principle. I will just run through it quickly. We've got a cold area from where heat enters my cycle by, for instance, evaporation of the fluid. Then go through a compressor, so increase pressure. So go through a compressor. Then go through a boiler. In this boiler, heat is rejected to the volume, to the hot region, and then expand my working fluid again to make the cycle actually work as a cycle. And over here I've got my hot region, and my objective would be to increase the temperature in this hot region, so add heat to the hot region. A couple of things you need to take into mind. This is not a, for instance, not a refrigerator or an extremely cold area. This may be outside. Maybe the temperature outside is even warmer than inside. So, but this is just another region where the temperature is assumed to be cooler, but it doesn't necessarily need to be cooler over there. And this is the hot region, for instance, your room. Having explained the working principle of a heat pump, I'm now going to derive the coefficient of performance. And it's just a recap of the previous lecture. The coefficient of performance was the required. The energy required over the required input. Okay, so let's calculate this for a heat pump. The coefficient of performance for a heat pump. The energy required, so is now on the contrary to my cooling cycle, is now the Q hot out, and the required input still is the work I have to add to my compressor or pump. For instance, your central heating system in your house, it will be a pump. Now I'm going to, of course, after this, so this is basically the coefficient of performance for your heat pump. Now I'm interested in the Carnot efficiency, so the efficiency compared to, of the efficiency I could have in the most ideal situation. And like in the previous lecture, I'm quickly going to draw the TS diagram of a Carnot heat pump. And we've got the T, we've got the S, We've got a high temperature, or T hot. We've got a low temperature, or T cold. And the cycle looks like this. Horizontal line, and another horizontal line. I'm adding heat over here. Q cold in, and I'm extracting heat Q hot out over there. So here we have the Carnot cycle again. And well, to determine the coefficient of performance for a Carnot cycle, well, again, I cannot use my work input, but I have to use the difference between the heat output and the heat input. So my coefficient of performance for a heat pump will become the Q hot out divided by Q hot out minus Q cold in. Divide everything by Q hot out results in 1 over 1 minus Q cold in over Q hot out. One thing I know from the Carnot cycles is this. So just put it away here in this box. And that is, I have to, is that this should hold Q cold in over Q hot out should be larger than or equal to T cold over T hot. Okay, if that holds, then I can substitute this. So I got my coefficient of performance for a Carnot cycle. Now I'm going to substitute this into this. And then my Carnot efficiency for a heat pump will look like 1 over 1 minus T cold over T hot. So actually this is basically all I have to say about a heat pump. Of course, there are many examples of heat pump, for instance using heat from the core of the earth to heat your houses, or from some electricity source or whatever, or from maybe a waste heat from some place. But at least you know of a basic heat pump, the principle and how it's used. And of course, I hope you will be happy that you're able to determine the coefficient of performance and the coefficient of performance if it were a Carnot cycle. Thank you very much for watching, and I hope to see you in the next movie.